So this is my midterm presentation for Math 2B. Now number 1, it says consider the 4 functions defined below. We have 4 different functions, and what we're going to be doing is labeling the functions on the graph. What I found the easiest to do for this was to find a graphing calculator and plug it in. So here on the screen I have this graphing calculator, and I've already plugged in the first one, which is negative x plus 1, so p of x. And we come over here to the graph, and we notice that the point right here is at 1, 0. So if we come back down to our graph down here, and we look at the ones that stop at over here and stop at 0.10, we notice that it's this one. So this one is P. Okay, now we're going to go up back to our graphing calculator, and we're going to graph Q. So we're going to type in our square root, and then we're going to type in negative x minus 1. Okay, and we come over here, and we see that it is at negative 1, 0. So we're going to come back down to our little graph and look for the one that's at negative 1, 0. And we see that it is this one right here. So that one is Q. Okay, and we're going to go back up here onto our big graph. We're going to graph the square root of x plus 1, which is r. So we have square root of x plus 1. Oops, I put x equals 1. Plus 1. Okay, and we come over here, and we see that it is also at negative 1, 0, but it goes to the right. So we're going to go down here to our graph and see which one that is. So negative 1, 0 is right here, and it comes to the right would be this one, so R. Okay, and now we're going to go back up, and we're going to add our final one, S, and it is the square root of x minus 1, so it's minus 1, and we come over here and we see that it starts at 1, 0, but it goes to the right side. Now if we come over here, come down here, we see that is that one, but it's also our last one, so that one is S. Okay, and for number 2, it says counting the number of cricket chirps can provide an estimate of the temperature. The formula below gives the temperature in degrees Celsius based on the number of cricket chirps in 15 seconds. What we have is C equals 5n plus 40 over 9. This formula can be rearranged to solve for the number of chirps as a function of the temperature in degrees Celsius. Which formula has been rearranged correctly? Since we'll be solving for n, the first step in this would be to just go ahead and multiply both sides by 9 so we can cancel it out on this one side. So we'll write it down here. C equals 5n plus 40 divided by 9. So we'll multiply this side by 9 so it'll cancel, then multiply this side by 9. So we now have 9c equals 5n plus 40. So what we do now is we subtract 40 on both sides, and it's going to cancel out on the right side. So we subtract 40. We now have 9c minus 40 equals 5n. Now, you're thinking, since we have 2 variables, what do we do? Now, what we're going to do is divide both sides by 5. So that means we're going to divide this whole side as 1 by 5, and then we're going to divide 5n by 5. So when we divide 9c by 5, we just get 9c over 5. And then we divide by negative 40 by 5, we get negative 8. Okay, and then when we divide 5n by 5, 5 divided by 5 is 1, so it'll just be n. We have n equals negative 9/5 c minus 8 equals n. So that's our answer. If we come over here and look at our answer choices, we see that that is answer A. So for number 2, answer A is correct. Number 3 says Brian has a mega ball with the volume 904.32 cubic inches. Sally would like to have a mega ball with half the radius length. Here's the mega ball. and it says, what would be the volume of Sally's ball? Okay, so for this, we're going to have to find the original radius on this one. Oops, sorry about that. Okay, so what we're going to do is take 904.32 equals the formula to find it, which would be 4/3 pi r cubed. Okay, so what we're going to do is we're going to divide both sides by 4/3 pi. So 4/3 pi, and on this side we see that it cancels out, so we'll just cross it out. So we get 904.32 divided by 4/3 pi, we get 215.89. Plug it in the calculator. We get 215.89 equals r cubed. Okay, so now what we do is we take the cube root of 215.89. What I'm going to do is I'm going to plug it into the calculator right here just to be sure that I get it right. Okay, so I'm just going to take this 215.89. Just a second. Calculator's not complying. Okay, and it says that we get 5.99, so the cube root r equals 5.99. We can round that up to 6. So we now have 6 equals r cubed. Okay, and so what we're going to do now is okay, and so we see that the radius of this ball is 6. So since we're looking, Sally wants half the volume, we have to take half of this. And we get 3. And so now we know that the formula is 4/3 pi r cubed, so we'd have 4/3 pi 3 cubed. And when we plug that into the calculator, we get 113.09. Okay, so 113.09. And we come over and look at our answers. We see which one is the correct and closest, and we see that that is D. The only reason the last two, the decimal is different, is because I used pi instead of 3.14, but that's it. Okay, so for number 4, it says an 8-foot ramp needs to be elevated at an angle measuring 10 degrees to be level with a step approximately. How far does the ramp need to be away to hit the edge of the step? Okay, so what we're going to do here is we're going to be using some trig function. So it says an 8-foot ramp. So we'll go ahead and draw the ramp. We'll label that 8 feet. Needs to be elevated at an angle measuring 10 degrees. So elevated, we'll say that that is our 10-degree angle. So 10 degrees right there. We'll draw that out right there. Okay, to be level with a step. Approximately how far does the ramp need to be away to hit the edge of the step? So what we're going to be doing is trig functions. So we're looking for the side adjacent to the 10-degree angle. So which would be this one. Okay, so we're going to find the cosine since we're looking at the adjacent and the hypotenuse. So we have cosine, and if you don't remember what cosine is, you can use the SOHCAHTOA formula, and we see that cosine is adjacent over hypotenuse. So when we take cosine of 10 equals the adjacent, which is x, over 8, to cancel 8 out, we're going to multiply both sides by 8. Cancels on this side, 8. So we have x equals, go to the calculator and we'll plug in cosine of 10 times 8, and we get, I think I plugged that wrong, we'll get 8 times cosine of 10, and we get 7 point. Okay, number 4 says an 8-foot ramp needs to be elevated at an angle measuring 10 degrees to be level with a step. Approximately how far does the ramp need to be away to hit the edge of the step? Okay, so I went ahead and drew the ramp. We have our 8 feet, our 10-degree angle, and our adjacent angle that we do not know. I went ahead and wrote the SOHCAHTOA so we could know what formula to use, and that's the cosine. So we plug that in. We have cosine of 10 equals x over 8. We multiply both sides by 8. 8 cancels out on this side, and on this side we get 7.9. Okay? So if we go up and look at our answers, we see that B, 7.9 feet, is correct. Now for number 5, it says the figure below shows right triangles inside a rectangle. Based on the figure, which equations are true? Okay, and so by the properties of the rectangle, we're going to be looking at the degrees, really. So first we have cosine of P equals sine of U. So if we look at cosine of P, so if we have P right here, cosine would be adjacent over hypotenuse. So it'd be adjacent over hypotenuse. So this and this is equal to sine of U. And sine is opposite over hypotenuse. So U, we have U right here. We have the opposite over the hypotenuse. And we see that that is correct. Okay, so for the next one, it says cosine of T equals sine of U. So cosine, remember, is adjacent over hypotenuse. So cosine of T, we have the hypotenuse and the adjacent. Okay, there's our T. Is equal to sine, opposite sine of U. We have the opposite over the hypotenuse, and we see that those two are equal, so that one is correct. The next one says cosine of P equals sine of Q. So the cosine of P, remember, is this one right here, is equal to the sine of Q. Where's Q? Q is right here. Okay, we have the hypotenuse and we have the adjacent. So there we go. That is correct as well. So let's circle that. We have cosine of R equals sine of U. So R, we have adjacent and hypotenuse, so it's this triangle. And sine of U, so we have this triangle. We see that that one is not it, so we will not circle it. Okay? And so for this one, it says cosine of Q, this, is equal to sine of T. T's right here. I crossed it out so much. This is equal to this. That is correct, since they are part of the same line. That is correct. And then cosine of Q equals sine of U. So here's U, Q, and here's U. That one is not correct, so we won't mark that out. So the ones that are correct for that one are cosine of P equals sine of U, cosine of P equals sine of Q, cosine of Q equals sine of T, and cosine of T equals sine of U. For our last one, number 6, this one's a bit tricky. I've been talking so much now. Okay, so what we're going to do is we're going to be solving for x, obviously. And the thing is, we're going to be using the angle similarity. Since angle STR, this triangle right here, is congruent to itself and to angles PQ, right here, I'll just PQ and R and TSR, and they're both, this angle and this angle are both 90 degrees. So what we're going to be doing, we'll write PQ over TS equals 5/3. Okay? And that's the ratio for all the sides. Because if we take 10/6, so let me show you, we have 10/6, we divide both sides by 2, since that's what they're both divisible by, we get 5/3, right? So that's our ratios for all the sides, so that's why we have this. Okay, so now if we take 15 divided by our ratio for all the sides, 5/3, and we flip it to multiply, we get 15 times 3/5. Plug that into the calculator. 15 times, we get 9. 15 times 3/5, we get 9. So x equals 9, and that's it.